In this video, I'm going to explain the notes of 7.2, which is about removable discontinuity, which are also known as the holds of a graph, and also about vertical asymptotes and how they could be found in the process. So just to give you a visual, I searched online what holds in irrational functions look like. And if you notice, all these images just show the holds with little circles on graphs. So for example, right here, there's a little hole. Right here, there's a little hole. So this is how you can tell in a graph where there are holes. However, the calculator we use in class does not show you that hole, but it can show it to you if you knew what value you're looking for, which is what the notes are about. I'm going to show you algebraically how to find the hole, and then you can use your calculator to verify. So the notes had the example of y equals 2x plus 4 over x squared minus 4. And it showed you that if you graph this, this is the standard form. But you cannot find the whole using standard form. You have to convert standard form into factored form. So that will be your first step. Turn this standard form function into factored form. You're going to look at the numerator and think of what are the factors of 2x plus 4. 2x plus 4 have 2 as a GCF, so we're going to factor out the number 2, and we are left with x plus 2. And there's nothing else we can factor here, so these are the factors for 2x plus 4. On the denominator, we have x squared minus 4. So you need to look at this binomial and ask yourself, how can you factor that binomial? This binomial is special. It's the difference of squares binomial, which means that we can immediately turn that into two binomials that would look like this. X times x will give you that x squared, and 2 times 2 will give you that 4. But we have to put a plus and a minus on each. So these are the two binomials that you get whenever you have a difference of squares. So now that we have this in factored form, we're going to identify if there are any factors that are identical on the numerator and denominator. In this case, x plus 2 is the factor that is identical, so we're going to write it down and use this factor to find the whole. We're going to equal this factor to 0 and then solve. Minus 2 on both sides, so we can cancel, and x equals negative 2. What we just discovered is where the hole on the graph will be at. It's when x equals negative 2. That means that we need to specify in our domain that x cannot be negative 2. If it is, it's going to give you a 0, because negative 2 plus 2 is 0, and 0 times anything will give you 0. And that's what we want to try to avoid. We want to try to avoid having a 0 as a denominator. So this is how you calculate the whole. Then any factors remaining in the denominator, you're going to identify those as the VA. So you do the same process that you did here, but now this is for vertical asymptote. We solve by putting equal to 0 and then inverse operations, so x equals 2. This is where the VA exists. So keep in mind, through color coordination, what is found based on the steps in the process. Once you find these two values, you have to kind of summarize your work by saying, oh, my domain is any x value in the function such that x cannot be these two values. So any value works except for these two in the graph. And that's it. That's all that you do in this topic. So I'm going to go over 2 more examples that the notes had, and then you should practice just to make sure you truly get it. If you want to pause the video as we do these examples, you can, and then just play it to verify that you did it correctly. So the first example in your notes was x squared minus 16 over x squared minus x minus 12. And again, this is standard form, and you need to turn it into factored form. So to turn the numerator into factored form, we need to again notice that this is a binomial. And when it's a binomial, most likely it could be a difference of squares. So you want to check for that. To check if it is a difference of squares, you just kind of ask yourself is it something squared minus something squared. X squared is x times x, and then 16 is 4 times 4. So yes, this applies. That means we can write two binomials that would look like this. X times x for x squared, 4 times 4 for 16. One with the plus, one with the minus. For the denominator, though, you have a trinomial. Anytime you have a trinomial, you want to consider using the strategy that we did in class of writing an x with a times c at the bottom, at the top, and then b at the bottom. So a times c, it's 1 times negative 12, and then the b is negative 1. What two numbers do you multiply to get negative 12? And what two numbers do you combine to get negative 1? So looking up is what do you multiply, and looking down is what do you combine. So 3 and 4, 3 times 4 is 12, but in order to get negative 12, one of these needs to be negative. So if you look down here, we need negative 1 as an answer. We need the 4 to be a negative. 3 minus 4 is negative 1. So this is the combination that will work. Whenever your a value is a 1, what you can do is immediately, as soon as you find these two numbers, you can immediately write your two binomials already. So you're going to write x, this is a positive 3, so plus 3, and then x, and this is a negative 4, so minus 4. And again, this trick only works whenever the a value of the trinomial is a 1. So now this is the factored form of that example. And when we have that, now we proceed with the process of looking for a factor that is identical in the numerator and denominator. In this case, x minus 4, which means that we're going to identify the whole by writing x minus 4 equals 0 and then solving. So adding 4 to do inverse operations, and then x equals positive 4. That's where the whole will be at. And the remaining factor in the denominator will give you that VA, the vertical asymptote. So we solve it as well with inverse operations. X equals negative 3, and this will be your VA. So once we identify these, we want to finalize by stating in our domain that all the x values are okay to use except for these two numbers. So the set of all x values such that x cannot equal negative 3 and 4. Okay, so one more example. Your notes had the example of y equals x squared minus 4x minus 5 over 3x squared minus 75. And once again, this is standard form, and we need to turn it into factored form. So to turn this into factors, we need to look at the trinomial at the top. And again, every time you have a trinomial, use that strategy of the x, a times c, and then b, to help you turn that into two binomials. If you cat on to the problem, the pattern, then you don't need to use this x if you already know what to look for. But let's just go ahead and continue. So 1 times -5, that's your A times C. That's -5. B value is -4. And then what two numbers do you multiply? What do you multiply to get -5? And you combine to get -4. So 1 times 5 gives you 5, but we need -5. So that means one of these is negative, and we need -4 as an answer. So it has to be 1 minus 5 to get -4. So these two numbers are the ones we're going to use. And once again, the A is 1, so we can just easily write the factors. This is the positive 1, so x plus 1. And this is a -5, so x minus 5. On the denominator, we have a binomial. So when we have a binomial, we need to check if it's difference of squares. And if you think about it, here we first need to do a GCF. GCF is always the first step before any other step in factoring. So 3 has, it's a factor on both of these. So we can do GCF of 3, which will result in 3x squared minus 25. And that x squared minus 25 is something squared minus something squared. That does give you that difference of square of x squared minus 5 squared, which means we could write down our two binomials for the difference of squares, but we also have to write that 3 in the front that we factored out initially. And the difference of squares will give us the x plus 5, x minus 5 binomials. So y equals this right here. Now that you have the factors, you continue with the process, which is find identical factors on the numerator and denominator, which are these two. And these two will give you the whole. So you just write it down one time and then you solve for it. Add 5 to both sides to cancel, and x equals positive 5. So again, that will be your whole. The other part that you can find is your VA, which is with the other factor that's left in the denominator. So the VA is going to be found through x plus 5 equals 0, minus 5 on both sides, x equals -5. So that will be your VA. And when we finalize this, we're going to specify that our domain is the set of all x values such that x cannot equal -5 and 5. Okay, and some students asked about the 3, and my response to that was we are trying to find values that are going to give you that 0 on the denominator. If you look at the factor of 3, the 3 will never give you that 0 as the denominator. But this factor of x plus 5 will give you a 0 if that x is a -5. And this other factor of x minus 5 will give you a 0 if this x is a positive 5. So by finding those values, we now need to just write down which values we cannot use, because if we use them, we will get that 0. So that's this topic. I hope you understand it, and let me know if you have any questions.